Resume. Okay, so going through this here, just make sure you get, just put your name. I'm gonna put my name on here. This way you'll never ever lose it. It's all stapled together. If you want, you can put it in your binder and remove the staple. Or if you want, you can kind of leave it how it is. Just please don't lose the pages. If it ever starts to fall apart, put it in a binder. There are little page numbers on the bottom, but that's going to suck to organize if that ever falls apart. So there's 4 lessons here, right? So once you just go to the table of contents here, just put in 124 to 125 here. So if you end up like getting ahead or you want to get challenged more, that's where you can go to the textbook and you can find some of the exercises there. And so the textbooks are either online or they're in the back of the room. And so it is the Math Works 11 one, of which, this one. It's not the primary thing we're using, but if you feel like you want to get challenged, you can get extra stuff there. Yeah, it's at the back of the room there. You don't need it right now. Yeah. So we're going to go just straight up into it. So surface area of prisms. Now, we have an idea what surface area is, right? It's like the amount of space something takes up. When we go to this floor here, and I don't actually know how big it is, but normally we see these squares, so like, a foot by a foot, something like that. So like, if I were the contractor in charge of doing this foot, I'd say, yeah, this is like, 15 inches by 15 inches. It takes up this much surface area, right? And there's ways we can get that. And this stuff shouldn't be new to you, but over here's a formula sheet. You'll get more of these later. But this is a formula sheet to find the surface area of just basic shapes. And we can use this to make some complex stuff later. But so I'm just zooming in here. If I go to like this one here, so this case, a rectangle in this case is, area is length times width, right? That's what the L and the W mean here, which means I would take whatever number this is, times it by whatever number that is, that's going to give me my answer. So if in this case, if the area here is, it's like 5, the width is 2. Oh, well, this is 5 times 2 is 10, right? So basically, it's just substitution. So that was the thing that we had practiced on Thursday, but you're just substituting numbers in for the values there. Now, this one here, this is a square, right? A equals s to the power of 2. That technically, it just means s. Remember, little dot means times. S times s, right? S squared is just s times s. You're just taking a side times another side. That's the exact same thing as a rectangle. It's just in this case, it's the exact same side. For a parallelogram, so this one tends to confuse a lot of students. And so what I want you to kind of do is like take a look at what I'm doing here. So you don't do this on your sheet, but for the parallelogram, this is the exact same formula as a square, right? Technically, like base times height, right? It's how long it is times how high it is. The reason that's the case is, so if I color all this little part in here, best I can with my little mouse and this stuff, it's not very elegant, but if it works, it works. So if I were to like cut this off, if I cut this off, I could put it right over here like this, and all of a sudden, what I have there is, I have myself just this nice square, right? Or a nice rectangle. So that's why it's technically the exact same formula. It's the length times the width, the base times the height. They technically mean the same thing. But a parallelogram is just a square that kind of got like, it has a slanted end. But if you were to cut that slanted end off, move it to the other side, boom, you'd have a perfect rectangle. And then finally, we have a triangle here. Now, triangle is just 1/2 times your base times your height. I'm going to give you another example of a triangle here. So right down here. So this is a triangle, right? So again, it's like, you don't notice this. Like pretend this 1/2 doesn't exist here. Base times height. That's the same thing as a parallelogram, which is the same thing as a rectangle. The reason you get the half here is because technically a triangle is just half of a rectangle. A triangle is just half of a rectangle. If I was to take this thing, take another one, combine them together somehow, you just get a full rectangle. So if you know like how to find the area of a rectangle, you can kind of use that to find all the other basic shapes except the circle. But that's why we get the half from here. It's just because it's half of a rectangle at the end of the day. Let me just erase all that lovely stuff here. And circle. So this one here is A equals pi r squared. So I'm going to go into pi in a second, but so remember, so pi r squared just means r times r, right? That's what that means. So this is pi times r times r. What does the r stand for here? Radius. Yeah, boom, it's radius, right? That's half the length of the circle. Now, does anyone know like where pi comes from? Sorry?
The Pythagorean method?
Oh, the Pythagorean? Not quite, but I like where your head's going. So where we actually get pi from, or rather like what it means. So technically, like pi is a symbol we use in place of it. Because if you were to put the numbers for pi, it's like 3.14159, and then it goes on literally forever. It has like 50 million digits. We're lazy, we don't want to do that. So what do? We just write pi. And we write pi, we know what it means. So where it actually comes from is if I were to take a circle, this thing here, if I were to take a circle and I was to let's say like what's the length around this full circle? Let's say it's just one. Let's just say this is, I don't know, 1 meter or something. I'm making up a random number there, it's not a meter, but let's just pretend it's one. If I were to take this whole thing, I were to just pen or a marker. If I were to roll it out, so I take this whole thing, I were to roll it out, such that the black is always. Okay, that was not intentional. Bear with me a second. Oh, that's why I saw some massive. Oops. Sorry? No, it's just a gender neutral term I've tried to adopt. Okay, I'm not going to do a live example, but basically, if I were to take a whole piece here that came off cleanly, which is not, it would be 3.14 times longer than this whole thing. It is around here. So basically, where we get like pi from is just it's a. I'll show you a better example later once I get the tape working. For the sake of time, I won't, but I'll show you where it comes from. But in this case, the formula of pi is just you take pi, you times it by your radius twice. Pi times radius times radius. So this is a trapezoid. This is different than a parallelogram because a parallelogram, you have this line here goes all the way across, right? It's a parallel line. It's the exact same angle. It's the same size, everything. If you extended these lines forever and ever, they'd never touch. That's why it's called parallel, right? Trapezoid's different because you have the lines go in different directions. Eventually, these things would touch. If you were to... Wait, what? You just got here. So with the trapezoid here, that's how it's different than a parallelogram, is that eventually, if you kept these lines going, they would touch. This is a really complicated formula, right? This looks harder than the other ones, right? Because now you're doing a half times your bottom side plus the top side times the height here, right? So this one's a little bit more complicated. But that's a trapezoid there. So those are the basic shapes. Now that's not the primary goal of today. We're going to be doing prism stuff later. And I'll show you what that means in a bit. But basically, a prism is a 3D shape. We don't need to really know the rest of it. You know, it has congruent parallel polygons and sides that are parallelograms. Like it's a 3D shape. If you see a 3D shape, it's going to be a prism, at least in this class, or a sphere or something. So this is the big thing that we need to know, just what a prism is. And you'll see some examples of this in a bit, but it's a big 3D shape. The other two really important things you need to be aware of is net and surface area. So yeah, that's the box there. Yes. save that for a bit. So basically, if I was to get rid of all this space here and like lay this flat, that would be what it measures, right? And when you pull them all up, that's when you get a shape. And then the surface area is just the area of the outside, like it's the area of the outside surface. It's all the stuff around it. Like one of these tiles has a amount of space that it takes. That's what surface area is. So if I were to do this first one here, first off, what shape is it? It's a rectangle, right? Right? So in this case, okay, well, what's my formula to find the area of a rectangle? Yeah, area equals length times width. Does that understand where I'm getting this A, L, and W? Again, we're lazy. So we use those instead of the full thing, because that would suck to write the full thing. Okay, so my area, A, is equal to my length, which is L, which is, what's my length? 6.8. 6.8, yeah. Not only 6.8, this is a common mistake people make, 6.8 centimeters. You have to pay attention to these units because eventually there'll be a question that's not going to have the same ones. And then what's my width? 4.5, right? Yeah, 4.5 centimeters. And so when I multiply these together, because that's what it's telling me to do, right? Length times width, what does that give me? Ooh, so that's if we're finding the perimeter. In this case, we're finding the area though. So we're not trying to find the full perimeter. We're trying to find all the stuff inside. And to do that, oops. Sorry, what was that? Yeah, so it's 30.6 what? Because we always have a unit of measurement. Centimeters squared, right? That's that little 2 there. So when we see the 2 there, that's how we know that it's measuring the surface area. So now if I wanted to measure the perimeter, which is all the stuff, that's just how far long the outsides are. Well, in that case, that's just gonna be regular centimeters, right? It's not gonna be square, it's just gonna be regular centimeters. In this case though, because we're finding the area, we're finding all the stuff inside, we're multiplying them together. I can show you a little bit a better demonstration of that with those blocks later, but we'll come back to that. So, okay, so again, with these things, oops. So for number B here, you're gonna have to write this one below. I apologize. I know it's not very space friendly here. Again, figure out what shape it is. What shape is it? The triangle. What's the formula to find the area of a triangle?
Number 2 times base times height.
Yeah. Now I'm just writing 1/2 BH. Remember the time symbols are there. They're just invisible. We know if we see a 1/2 BH, it's 1/2 times base times height, right? So what is my base in this case? Yeah, this one is actually 12.8. You betcha. So 12.8. And what's my height? Like 12.8 centimeters. And what's my height?
7
times 7.8 centimeters. So if I put that all in my calculator, what does that give me? Oh, so I think what you did was you did 12.8 times 7.8. Remember, want to do a 1/2 times that.
Half?
Yeah, yeah.
But don't we just divide that by 2?
Yeah, you can divide it by 2. Yeah, that's what a 1/2 is, right? You cut it in half.
49.9.
Yeah, so this one is 49.92. Yeah, 49.92 centimeters squared. So again, you had the right method. You just made a simple calculator mistake, right? That's why we show our work. 0.92 centimeters. Centimeters what? Squared. It's gonna annoy you me saying that all the time. So I apologize in advance. So number C here. What's my first step? So, thank you. Letter C. What's my first step for letter C? Let's figure out starts with an S, rhymes with ape. Figure out the shape, right? It's a parallelogram, right? So what's my area for a parallelogram? Or what's my formula for area of a parallelogram?
Area equals base times height.
Yeah, area equals base times height. Right? So what is going to be my base in this case?
I think that's 3.1 meters.
You betcha, it's 3.1 meters. And what's my height? And 2.1. So not, oops, that's a bad 2. The 2.1 meters. Now, I'm gonna give you another unit of measurement here, and it's gonna be this red line. If I was to tell you this one here is 2.5, which one would I use for the height still? I'd use 2.1, right? When it talks about height, it wants to know the stuff that goes straight up. That's it. It's like a rocket, straight up in the air, nothing else. If it's at an angle, that's not the true height of it. It's just the length of a side. So when it talks about height, it goes straight up in the air and that's it. So so if I multiply these out, what am I going to get?
I got 6.51 centimeters squared.
Oh, now it's not centimeters squared, it's meters squared.
Almost.
Yeah, you wouldn't get dock marks for that, by the way. I get what you were saying. So 6.51 meters squared. So the area of this thing is 6.51 meters of it. Yeah. And then for number D, we know which letter D. We know what shape it is, right? This is a circle.
I think is it, are we looking for the area?
We're looking for the area, yeah.
Area equals pi r.
Equals pi r squared, right? So perfect. So if I substitute these values in, then pi is just pi times, oh, so it's times, oh wait, what is?
The pi.
Oh, pi is technically 3.14159.
But isn't it just like we have to use something?
Oh, I'll bring that up into you in a second, actually. So I'm going to show that on a calculator. That's what I have here. So it's pi times radius, which is 4.5 squared. If you want to write just 4 times 4.5 centimeters. Now remember, it's not times 4.5 centimeters squared. It's times, yeah, it's times 4.5 centimeters. The whole thing is squared. Not the centimeters aren't squared. The whole thing is. If that doesn't make sense, you can just do 4.5 times 4.5. That is totally cool. So when we're talking about pi here, some people want you to like memorize, it's 3.14159 or 3.14, something like that. We don't need to do that because you have a button on your calculator somewhere for the symbol of pi. So that's what it is, right? Sorry? So you know what? I'm bringing the same calculator for everybody. So everyone has a different calculator right now. So I'm not going to show anyone how to do that. We will show you tomorrow once I get them, because otherwise I'm showing everyone how to do it differently. But so in this case, I take my pi. So I pressed pi, it gave me this number, right? I'm timesing that by my radius. So 4.5
So that's what
times 4.5 equals 63. Now, I don't write this.
twice?
Sorry. Well, I'm gonna show you something in a second here. So I have a whole huge number here, right? I don't need to be that exact. You could have a rocket going from here to the end of the universe. You only need like 10 decimal places to get it there accurately. So I'm just going to round it down to like 1 or 2 decimal places here. So 63 point, I'm going to say, so not 6.1 because the 7 here is the next, so 6.2. It'd be 6.2.
Okay.
I'll tell you specifically like, how much to round it down to, but as long as you round it down to something, like that's the important thing here. So I want to show you a common mistake a lot of people are going to make on the calculator specifically. This is why it's really important to understand this squared thing and the order of operations. So what I did here was I did pi times 4.5 times 4.5, right? If I was to do this calculation, where's my C? Clear. Oh, right there. If I was to do this thing again, so I'm taking pi, I'm timesing that by 4.5. This little symbol here means squared, right? Oh, okay, it did do it on your calculator. I guess what we'll come to that. We'll come to that when we get the actual emulator. Never mind then. Okay, so that's the basic shapes, right? So you guys do have that on your book there. Now, where it gets to be just a mean question is this. This is not a basic shape. So, but I can find the surface area of it, right? You're gonna need to do stuff like this if you ever need to do like the flooring of your basement. I did that like 2 months ago. I had to do this. So how could I possibly, this is not basic shapes, right? But how can I find the area of this? What's our guess? What can I do?
You add the 13.4 plus 6.8 plus 3.1 plus 6.2, and then you take the 12.6 centimeters or whatever, you cut that in half.
So you're on the right, I think I see what you're saying here. You're on the right track. How we're going to find the area of this? This is called a composite figure, right?
Could I add them all together?
You betcha. We're gonna have to add not those not the lengths. We're not going to add the lengths together, but what we are. Oh, sorry. I'll get there. So composite figure. So you're right, Stephen. So what we're going to do is, this is not a basic shape, but I can turn it into a basic shape. So what I'm going to do is I'm going to split this up into squares and triangles with 2 lines. Oh, I can do this now. I know how to find the area of rectangles. There's 2 rectangles, and I know how to find the area of a triangle, and I add them all together. Simple in theory, but there's a couple things wrong with this. So and before I go into that, again, with composite shapes, that just means you're taking a bunch of simple things, you're putting them together. So any video game you've ever played, everything's made of triangles or like polygons and stuff. Now, like if you ever go to like the really, really old days, I meant to have this loaded up in advance. I knew I was forgetting something. Here we go. This is always the one that comes to mind for people. And open image in new tab. This one. Old school video game, right? Laura Croft. Everything was made with like really basic shapes here, but they made a complex figure. This was like top of the line graphics back in the day. Not so much anymore. But composite figure is just a bunch of easy things put together. That's what this is. So all of a sudden, I can figure this out. But there's going to be a step I need to do first. So first off, I already did step 1, which was, so step 1. Turn it into simple shapes.
Did you just write this in there?
You can write that directly in there. Yeah, you bet. If I zoom out this much, is everyone able to see? I think you have your booklet there. Oh yeah, feel free to like follow along. You can open it up and write with. Okay, I'll zoom in a bit. It's in that top corner though. So turn into simple shapes. You bet. So turn into simple shapes. That's what that is. That's step 1. We've done that. We have 2 rectangles and a triangle. Now, step 2 is we're going to actually label each shape. A lot of the math we're going to be doing this unit is basically just keeping organized. Like you'll understand what you're doing, but you might get the wrong number there because like you didn't keep yourself organized. So, so we're going to label each shape. And so let's do that now. So label each shape, right? I'm just going to say this is shape A. I'm going to say this is shape B, and this is shape C. You can put whatever you want there. I'm just doing ABC.
So we have to do this, all this. Okay, well,
Mhm.
what would be? So 13.4 centimeters.
Ooh, I like where your head's going. That's the next step here. So once we've labeled it, you're looking ahead to exactly what we need to do next. We need to find the length of all the sides. We have a length of a lot of the sides, but it's not the ones we all need. So find the length. I'm gonna find the lengths with an S at the end of all sides. I'm gonna need to get like a way to type on here. Okay. So we turned it into simple shapes, we've labeled them, and now we need to find the lengths. And this is the harder part of it. Oops, step 3. So if I'm going into here now, so Kim, where your head was going here is you're like, oh, well, this whole side, the one I'm doing in blue, don't copy this, but this whole thing here is 13.4 centimeters, right? Cool. That doesn't help me directly though, right? I have, my two shapes are split along that. So I need to figure out how big this line here is. How can I possibly do that? What do I know?
So that's a square, so it would be 6.8 centimeters.
We don't know if it's a square though. We think it might look like one, but we're not sure. So we have to look at what we actually know, what the graph tells us. Again, I like where your head's going.
Maybe not, because it's
If you
6.2
go by
centimeters,
height,
right?
Equals base times height.
But there's an extra 0.2 centimeters somewhere.
So here's the thing. So we know this whole thing. So we know this whole thing here. Does it make sense where I've got this line? It's 13.4 centimeters, right? This whole thing is 13.4 centimeters. I got that number just from down here. It's an imaginary line, but one thing I do know is that this part here that I'm doing up and down, this part here is 6.2, right? So if I know the whole thing's 13.4 and 6.2 of them is dedicated to this line here, to figure this out, can I not just do 13.4 minus 6.2? Oh, we're just finding the length of this line specifically. So in this case, I'm going to get 7.2 centimeters. So what I have now is I have the length.
Yeah, that's what.
So I have the length of just this line now. And also this line, right? These are the same lines.
So it's not a square.
It's not a square, right? We've determined it's not a square because
It would be a weird rectangle.
it looks close to a square, but it's not a square. It's very close to one though.
Because there's like 24 centimeters.
Yeah, it's a little bit longer, right? So it's just it looks like a square, but it's a rectangle. But now for shape A, I now do have my dimension. So let's quickly do that. So let's do step 4 now, which is find the area of each shape. Oops. So find the area of each shape. Oh my gosh, that's an awful H. Hey, he's back. So step 4 is find the area of each shape. So remember, I told you, half of the battle here is going to be keeping organized. So what we're going to do is we're going to very clearly label stuff. As you get more experience, you can kind of start like doing this in your head and whatnot. But you really want to make sure you keep it organized here. So let's just figure out the area of shape A now, right? That's just all of this stuff in here. So I'm just gonna literally do this. Shape A. So now we're going back to exactly what we did. So Austin, you have a little work booklet there in front of you if you want to be keeping track with us. So we have shape A, which is this little part here, right? So it, length times technically width, but also height. Yeah, they mean the same thing. So we know it's a rectangle. So I'm going to get my formula, right? Oh, I know it's a rectangle. I know the formula for a rectangle. Boom, I've got it there. And now all I'm going to do is I'm going to substitute my values in. So my area is my length times width. What's my length here? It doesn't really matter, to be honest with you, in this case. So 6.8 centimeters. What's my width?
7.2.
And how come it's 7.2 and not 13.4?
Because you're not doing shape B.
Yeah, well, I'm not finding, I only need this part of it, right? And I know this part of it is just 7.2. So yeah, you're not finding this, you only need what you need. We're only finding the shape of the area of this shape right now. So that's times 7.2 centimeters. And if I calculate those out, that's going to give me 48.
Centimeters.
0.996 centimeters squared. Perfect. So the area here is 48.96 centimeters squared. Perfect. We're going to do shape B now. So I'm just going to write shape B down below. So if I'm writing shape B here. So again, if we're going to the sides here, I already know the length of one of these sides, right? We already figured this out. We figured out this line up here is 6.2 centimeters. It tells us that. This line right up here is 6.2 centimeters. But what I don't have, and I'm using green for this, I'm going to use green for this. I do not have the length of the other side, right? So how can I find that out?
Oh, just right.
So,
Sorry.
so I have the length of the blue line on the top.
Since it's 13.4, you have to take away 7.2.
Oh, you're right. I did do that, and I got that up here, right?
Yeah.
So we got 6.2 centimeters, but now I need to find the longer line. I need to find the one that goes top to bottom. Sorry?
Oh, 6.8 and 3.1.
You betcha. So I add the 3.1 centimeters with the 6.8 centimeters. Make sense where I got those numbers from?
Yeah.
I add those together. That's going to give me a total of 9.9 centimeters. Okay, I've got myself a rectangle now.
So it's just the same formula as the first one.
You betcha. It's a rectangle. I know the formula for a rectangle. It is area is length times width. Perfect. I've written that in. Now I just need to substitute my values, right? So what's my length? 9.9.
Yeah.
Yeah, 9.9 centimeters. And what's my width?
6.2.
6.2. So we're understanding why it's important to keep organized here, because one, you might have the right idea, you just put the wrong number in. You'll still get almost full marks for that. And two, there's just a lot of numbers, so it gets really easy to get confused after a while. But so if I multiply these in, area, so 9.9 centimeters times 6.2 centimeters, I should get 61.38 centimeters squared. Thank you. Cool. That's shape B. And we have our final shape, which is shape C. So shape C, what shape is that?
It's triangle, so I'm gonna go half times.
Yeah, so the formula for a triangle is 1/2 times base B times height. Cool. So we know. So what do we need in order to calculate this out? What two measurements?
The base and the height.
The base and the height. Yeah. So if I go back up to our shape here. I know my height. It tells me the height right away, right?
9.9 times 12.6.
So where'd you get 9.9?
Well, from that other line, 3.1 plus 6.8, and it's the same line.
Yeah, you're right. Like this is the same side, right? So like shape B and shape C, they share a side. So we know one of the shapes lengths, we know the other ones. Perfect. Now which one of those two numbers is the height?
I think that way.
The one that goes that way. We had to put a number figure to it. Is it the 9.9?
It would be the same because it's half of, you're gonna multiply the lengths.
We will, but I just think it's kind of important here. It's like what,
Well, I think this way is the height.
so which number is it, 9.9 or 12.6?
Well, you just lay it down, right, and it'd be the base.
I know what you're saying, but I need a number. Is it the 9.9? Is the 9.9 the base, or is the other one?
9.9 would be the base, the height would be 12.5.
You're right. You're right. So in this,
12.6?
yeah,
12.6, sorry.
you're right. Yeah. So the height here is the 12.6. Even though it's not the thing going up, we have to think about the triangle, right? The triangle's just shaped. It's rotated. So the height of the triangle is 12.6. It's not what we see, it's the height of the triangle itself. That type of skill will come in handy later. Right now, yeah, it doesn't matter. We have the two things. Later it will though. So cool. Going into this, I have my area equals a half times base times height. Cool. Let's substitute it in. So it's a half. My base is 9.9 centimeters. My height is 12.6 centimeters. So what does that all end up equaling out to here at the end?
I got 61.875.
You got 61.87.
9.9, 12.6.
Let's take a look.
I probably did that wrong.
Well, let's take a look here. I'm gonna load my calculator up here. So first off, I'm just gonna put 0.5. We know that that's a half, right? So 0.5. You could also just divide it by half at the end, but so I'm taking a half times 9.9 times 12.6. I got 62.37. 62 point. So Aiden, I think you just like pressed like 9.8 or something. Again, but like if you showed me this, like this work, and you just got the wrong answer, I'd just be like, oh, he just pressed the wrong button on a calculator. You're gonna press the wrong button on a calculator. That's fine. That's gonna happen. Okay, cool. I've got my answer. Am I done? You're right. So common mistake people are gonna make. You're right. I do. So I know the area of shape A now. I know the area of shape B now, and I know the area of shape C. A common mistake people are going to make is they found the area of each of them, and then they moved on. But remember, what is the question asking? It wants to know the area of all of this stuff. So how am I going to figure that out?
Well, you did all the multiplication and stuff, so just add them.
Just add them, right? I'm not going to multiply these anymore. I'm just going to add them up. Shape A plus shape B plus shape C. So I know the area of each of these. So that's going to give me... Okay, so step 4 is find the area of each shape, and then step 5 is add the shapes together. I'm going to put add / subtract actually, because I guess spoiler alert, that's going to come into play. This is a really crucial skill for most people in the trades. If you ever do like any home renos, it's a really important skill to be able to like do these composite shapes. So step 5 is we add or subtract the area of each shape. The area of each shape. Boom, perfect.
So what do we really get to, like, the degrees?
Like
Degrees of a triangle.
oh, that'll be unit. I don't remember what unit. It's in one of the units. It is in one of them. Okay, so
Because in roofing, right, that's the first thing you do, you
oh yeah, you try and figure out the slope and stuff. Yeah. Yeah. Like a lot of people, like when I go to high school, a lot of people think like, oh, this is the dumb math. No, it's the most practical math you can like possibly get. Like you use this in real life, 100%. So, okay. So we got our 5 steps. So the last step is add or subtract the area of each shape. In this case, I'm just trying to add it all together. That is going to give me, so what is this? This is, I'm not going to write the numbers in just for the sake here, but you know, so shape A plus shape B plus shape C. That's going to give me, screw it, I'll write all the numbers in for the first example. 48.96 centimeters squared plus 61.38 centimeters squared plus 62.37 centimeters squared. So first off, is this going to be centimeters squared or is this going to be centimeters to the power of 6? Squared. We're adding them. It's going to be squared. If we were multiplying this, that'd be different, but we're just adding it, right? This tile plus this tile plus this tile is still a surface area. It's still something square. Okay, and so if I add all these up, I'm going to end up getting 172.71 centimeters squared. And because, so here's another thing as well. I'm going to zoom out for a second. There's a lot here, right? There's a lot of information on this page. So a nice habit you're going to want to start getting into, circle your final answer. It will make my life and your life tremendously easier. So I circled my final answer. You could even make a statement. The surface area of the shape is 172 centimeters. I hated doing that as students. I'm not going to make you do that, so don't worry about that. But I beg you to please at least circle your final answer. You could even circle these things over here if you wanted to, as like, it kind of shows me where you're at. So any questions at all about this? Like, hard question, but we break it down into manageable steps. It makes a little bit more sense, right? The fact no one's saying, oh my God, it makes so much sense. It's worrying me.
I don't know. I just came not too long ago.
I know. We'll make sure we'll make sure you're able to kind of get caught up with the other stuff from before, but we're finding the area of shapes. Okay. Well, I want to imagine. Yeah, I'm just where are we at? We're at 1. Yeah, we'll keep going. Okay. I literally have it in front of me. What am I doing? Okay, so for these ones here, for naming these following prisms, this one here is just a, oh gosh. Oops, A is going to be a rectangular prism. Sorry? Ooh, great question. How do I know? Yeah, well, so first off, these are all 3D shapes, right? If it's a 3D shape, it's probably going to be a prism. You'll recognize the other 3D shapes as for what they're called, but if it's not something you do recognize, it's almost certainly going to be a prism. Prism means 3D shape. And how can I figure out what type of 3D shape it is? I look at the face head of it. What does it mean by face head? Well, it just means one of the sides. What is this? This is technically a square or a rectangle. We don't know for sure, so I'm just going to be safe. It's a rectangular prism, right?
I was just, never mind.
She assumed it was a person.
No, I didn't
Pyramid?
assume that. I thought I saw a square, but it looks like the top is longer than the sides.
Yeah, well, like I'll always tell you if it's a square or a rectangle. We won't always No, it won't always state it. But again, like if you just default, it's a rectangle, you'll never get it wrong, even if it is a square. Because you're still just taking it side times the side. So for this one here, this is a 6-sided prism. If this was 8-sided, you'd be like, oh, it's an octagon because octopus, 8 arms, right? This is 6. So letter B is actually a hexagonal. Hexagonal prism. I'm not going to test you on this, just so you know. I don't care that you can get the words for it right. So B is a hexagonal prism. Now C, what shape is it on the face? Triangle. So what would you think this is called? Triangular prism. You betcha.
What's the
Hexagonal prism. Triangular prism. Now, D, we're gonna say that D here stands for just a dick of a shape. It's a mean shape. The wording here is actually kind of weird. First off, what shape is on the face? It's not a rectangle. It is a parallelogram, right? Has those nice oh gosh, that's an awful line. Has those nice parallel lines on each side of it. So you'd think like, oh, it's a parallelogram prism, right? Or a parallelogramular prism, something like that. It's technically called and like, I didn't even memorize this. That's why I had to write it down. It's technically called a parallelepiped. Yeah, a parallelepiped. I will never, ever, ever test you on that. But if you're ever in like a bar trivia thing, maybe this will come up. Yeah, that's how you spell it. Have fun with that. Oh, sorry. ED at the end. There you go.
How we would find the area of that, we just find the area of the face times the left word.
Ooh, you're on the right track for sure. You're on the right track. That's kind of what we're doing next. So sorry, that's not what we're doing next. It's what we're doing later today. So okay, so we got the name of our 4 shapes here. The only ones you really need to know are rectangular and triangular. Like, who cares about the rest? Just know those two. You're good. So for number 4, I said it right for once. For number 4, again, read the question carefully. So now, what's different between number 4 and number 2? How are these different? Sorry? So how are 2 and 4 different?
Because the other one's flat and this one.
This one's 3D. You're absolutely right. This is a prism. This is a 3D shape. And whereas 2 was just it was just one side. It was a very hard side, but it was a side. And now for number 4 as well, the difference is for number 2, it just wanted us to find the surface area. For number 4, it wants us to know what would each piece of the cardboard look like. Remember, every box you make starts off with something like this. So if I were to, where's my scissors? This one we're not looking for the surface area at all. What we want is something called a net, which is what would it look like if it was a flat shape.
A net?
This is called a net. It's a net of a shape, right? When I fold it all up, it turns into a box, right? Nice 6-sided box. When I have it all flat like this is what's called a net. Little Valentine's little box.
And then you look at the shapes.
Yeah, I think I did something like that. But that's what go to the little floor. Okay, so that is a net of a shape. And so for number 4, that's what it's asking us to do. It's asking us, if you had a box that's like this, what would it look like if we got rid of all the tape and got rid of all the glue and just laid it flat.
So, oh yeah, there's the guys.
So it makes sense what we're trying to do. Where it gets hard for people is now we need to start thinking abstractly. So whenever we need to think abstractly, it's really important to know, what do we know? Literally state, what do we know? So first off, with this shape here, how many faces are there? The faces are the thing at the front.
5 faces. Times that by 2.
Ooh, you're on the right track. So there's 5 sides. So that's one thing we know. There's 5 sides, right?
8.
So there's 5 sides. Now you might be asking, how is there 5 sides? Well, there's one here, there's one here, there's one on the bottom, there's one on there's the opposite side of this one, and there's the opposite side of this one. There's 5. You're right. And then what about the front and the back? Or we normally call it the faces. It's the faces of the shape. How many of them are there? The front and the back. There's 2 of them, right? So there's the front and the back, or the 2 faces. There's the bottom, and then there's these 2 shapes here and the ones on the opposite side of it. So there's a total of 7 faces here. So I know whatever net I make needs to have 7 faces. And so if I were to, again, cut this all up and lay it flat, let's start drawing that. So first off, let's draw our faces here, right? And what's going to connect those 2 faces? What connected this box? There's always a central pillar, right? For this box, there's this nice long thing that goes all the way through. There's no cuts through it. It's just one big long piece. So that's like the core of it, right? And that's where your 2 faces, your 2 sides kind of fold in. So we know then that, okay, well, the 2 faces kind of looks like a little house here, right? The 2 faces are going to be connected through a long thing here. So what have I done? I now have the bottom and the 2 faces, right? Does it make sense where I got those from? So I now have, how many sides do I have here?
Yeah, and mixed up, I was thinking about pyramid.
Oh, I see. Yeah, this one's not a pyramid. Yeah, we're not finding the area of this. We're just trying to draw the net of it. So how many sides do I have here that I haven't drawn already?
And then you're supposed to have
We have 2.
2 on the side.
Do I have 2? Isn't there 3 things here? This is the bottom, this is the front side, the back side. Or the front face, the back face. I have 3, don't I?
But don't you have to add the folds,
Add the which?
like on the sides?
Like these?
Yeah.
You're right, I do. So I have 3 of my 7, right? So I'm missing 4 more sides. In this case, again, if I was to fold this box up, I have the bottom, there's this side here that comes up. So there's this side here, that's what folds up, provides that nice wall. There's one on the other side, right? Does it make sense where I'm drawing this from? That's the other sides. So this is the one I'm filling in right now. And then the one
You also.
over here is the other side. And then I need like the nice little like roof up here.
Yeah.
Yeah. Now, a lot of people might think, oh, don't draw this. Do not draw this. A lot of people think it might be something like this. That's not the case. It's just, yeah, it's just another rectangle. It's all the same length, right? And do that. Perfect. So this is going to be the net of that. And like nets are very hard because it's very abstract, because we don't have these nice, perfect models we can assemble and disassemble of every single shape. So it's really important to think about what you know. And what I know is that there's 7 sides in total. There's a bottom, there's the 2 faces, there's the 2 walls, and then there's the 2 tops. There's 7 in total, and then draw it from there. Always start with your core. On that box on the floor, it was that nice long rectangular piece. On this case, it was a nice long rectangular piece, which the 2 faces were attached to. So I hope that makes sense. Nets are very hard to understand. Okay. I think everyone's good to go. We're going to do one more here before we kind of send you off on your own for a couple minutes. So
Let's do a hard one.
we're about to do a hard one now. So number 5, it wants me to find the surface area of the rectangular prism below. Find the surface area of this, right? So before we don't even tell me numbers, how would I do that? Tell me in English. How would I find the area of this?
Area
Add them
equals.
together and then.
So we have two different things here. So one saying times all 3 numbers together, and you do that to find something, which we'll show you tomorrow. But how you actually find the surface area here? Again, if I told you to find the surface area of that box, well, you just measure each side. How many sides do we have on this? How many sides are on the shape?
One on each side.
Well, there's the 4 sides and the top and the bottom. There's 6 in total, right? So all of a sudden, all I need to do to find this is I just need to find the area of each separate side and add them together, right? Ooh, not quite. That's going to give us volume, which we'll get into tomorrow. But so in this case, so mistake number 1 is most people try and do this in just one step. You can't actually do this in one step. What we actually need to do here, we need to split the shapes up. Split and label.
So we put like.
So we're going to split and label the sides. Oh gosh, I did not give myself enough room here. Please make yours look nicer than that. So step 1 is.
You're not showing us how to get the answer. You're just showing us how to show our work.
Well, but you show your work to get the answer, right? It's very, you can't do it mentally. Like no one in this room, I couldn't do this mentally. You would need to write some stuff down. And so it's really easy to get all the numbers confused. That's why it's super important to keep organized here. So in this case, so all I need to do is I need to split and label the sides, right? So I'm going to have, again, side A, that's the front and the back. Side B, that's just the 2 sides. And then side C, which is the top and the bottom, right? So going up to here. So let's try and simplify this a little bit. So first off, we already know that these are all going to be rectangles. I don't know where my ruler went. I need that later. So let's just figure out. Let's figure out A. Let's figure out the surface area of A. What 2 numbers would I multiply together here to figure out the area of just this just A?
3.8.
Times 320. How come 3.8 and not 1.9?
Because that's the, it's like times. L times W.
Yeah. So like we're doing, so we're doing like, the reason we're not doing 1.9 is because that's how deep it goes, right? I only want to know A, and the only sides with A are the 2 I'm highlighting in some green here. Is this one, which is 3.8. We can figure that out because the other side of B is 3.8. And then this one here, which is 4.6. Use what we know to figure out what we don't. I didn't know the length of this, but I can use this to figure it out. So A is going to be, 4.6 meters. Oops, 4.6. Little dot there. Times 3.8 meters. And so if I times those together, what am I going to get? You betcha, 17.48 meters squared. So again, if you don't want to write like a novel for each of them, this shows your work. This tells me that side A is the length times the width, which are these, equals this. You can do that. That's a nice way to shorten how much you need to write down while also keep it organized, right? So let's go into side B. What 2 numbers am I multiplying here? 3.8 and 1.9, right? Because those are the 2 sides that relate to the shape. So 3.18 meters times 1.9 meters is going to give me You betcha, 7.22 meters. And then side C, what two numbers am I multiplying together there?
4.6 and
So 4.6 and 1.9, so close. We do 4.6 and 1.9. Oh, no, you're right, you're right. Sorry, my apologies. You're right, you're absolutely right. So yeah, 4.6 and 1.9, because those are the dimensions on the bottom. Sorry about that, Austin. Brain's not firing on all cylinders here. Times 1.9 meters. What's that going to give me? 8.74. 8.74 meters squared. Perfect. Okay, cool. So I've split and labeled the sides. Oh gosh, I'm not even gonna write the steps anymore. Step 2 is to find the area of them. I did not leave myself enough space. Now, am I done? What do I need to do next?
Find the area. Okay, all sides.
All sides? So do I just add all these three up and I'm done? Ooh. So I like where you guys are going here. And so Steven just said it, right? You're right. I do add all these up. I know what the area of the top is, the area of the right side, and the area of the front is, but there's 3 more invisible sides. So there's a couple ways you could do it. You could just figure out that, oh, well, the top is 8.74. The bottom is, oh, it's gonna be another 8.74. So you could just times each of these by 2, or you could add all of these together. So I'm going to plus all of these together. So 17.48, ooh, 17.48 plus 7.22 plus 8.74. Oh, I've made a terrible mistake somewhere. 7.4, oh my gosh. 17.48 plus 7.22 plus 8.74. If I add all these together, I'm getting 33.44 meters squared. But I am not done. All I've done is added up the 3 sides I know of. There's the 3 sides I'm not aware of as well. And you could either multiply these together, you could either you can add these all up together and then add it in. So you could do 33.44 plus 33.44. You could also just double it. Where did I get the times 2 from?
the
Other sides, right? It's going to be the exact same area, right? So that's just a nice, easy way to do it. So if I take the 2 times the 33.44, I'm going to end up getting 66.88 meters squared. And it's my final answer. So what do I do with it? You betcha, I circle it. So this is actually a harder question than number 2, but a lot less work for it. So there are ways you can reduce the amount you write while still keeping organized. You would get full marks for this. You could even write it directly in here, like A. So instead of you could figure this out here, oh, I know that this side over here is going to be, you did the math, 4.6 times 3.18. Oh, this one's 17.48 meters. That'd be fine too. I just have to understand how you're working with this, because now it's at the point where you can do it a whole bunch of different ways. So it's really important. You do still show your work, but you can do it in a way that is space friendly, if that makes sense. Okay. I want you to quickly go to page 10. I want you to hammer out questions 1 to 4. I'm going to give you till the break to do that before we keep going. So go over to page 10 and hammer out the 4 questions there, of which there are technically more. before we keep going forward. I'm going to pause my recording. Recorded. Okay, so continuing on with it, I'm just going to go straight to here for those answers. So for question 1 here, again, identify the shape, identify the formula, fill it in, and you're good to go. It gets a little complex though, as you guys noticed with 2 of the questions. So the answers are in red, and then any notes I'm going to make are going to be in blue here. So for the first one here, it's 6,082 and then 0.12 millimeters squared. Again, you just take pi, you times that by 44, and that's going to give you the answer. You're going to notice I shortened it to 2 decimal places. The answer your calculator gave you went up to like 8. You don't need to write that many numbers. It's okay to like round it down to like a decimal point or 2. That is okay. You don't need to write the whole thing. So number 1, that's the answer there. For number 2, this one's where it gets a little bit more tricky because, well, there's 3 numbers, but I only need to use 2 of them. Which ones is it? Well, for the base is always going to be a side of a triangle, and we do know 2 of them. We do know 2 sides. It's the ones I'm doing in blue here. But the reason we're not using 6.2, we don't use. I did the wrong thing here. Whoops.
No trust in my own health.
Yeah, so the reason we're not using 6.2 as the base is just because we also need to know the height, right? And the height is the thing that's going to go straight up from it. In this case, like look at what I'm doing here. I'm just highlighting like the 2 lines here. Oh, well, those are nice straight lines. That's going to be the base there. I have a height that goes straight up. I have a base that can go straight across, related to the height there. So I've actually done the wrong thing here. Times 5.7. What's that going to give me?
26.51.
Yes.
So sorry,
Meters squared.
26.51.
Yeah.
Whoops. We all make mistakes. See? So 26.51 meters squared. For number C, same thing. It's one of those. Now, at first glance, your first thought might be, oh, well, these are, this is like one of those 2 shaper ones we did before. We have to split them. It's not the case. This is actually a parallelogram. We know this because if I were to extend these lines out forever and ever and ever and ever, they would never, ever, ever touch those 2 lines, which I just made very not straight. So it's a parallelogram, which is area equals base times height. So same thing with this 14.81 here. This is one of the bases. It's one of the lengths of the side. This is also a length of a side, but the reason I'm not using the 6.8 centimeters is because I also need a height, right? So I'm looking for a base that has a height that goes straight up. So if you were to take your page, if you were to literally turn your page, so rotate it on your desk so that this 14.8 is flat, you then see that the 5.3 is the height. So sometimes you might need to get a little creative with like turning your page. Like I've seen people do it in final exams, whatever works for you. I mean, my brain's not too great with that stuff. For me, it's helpful to orient it properly. I literally will turn my page so that it looks right. So the reason we're doing 14.8 is because it's a base that has a height, and the height is 5.3. So I multiply those together, boom, I have my answer, 78.44 millimeters. Sorry, 0.44 centimeters squared. Then for number D, same thing. There's 3 numbers there. Letter D. Every time I just see Kim smile, I know I messed it up. So its area is half times base times height. Again, there's 2 numbers here. There's 2 possible bases it could be, either 13 or 16, but only one of them has a height. Only one of them has a height with it. So that way I know it's going to be 16 and 9. So 1/2 times 16 times 9. It's going to give me 72 inches squared. That's my final answer there. Okay. So I hope that helps like understand, like if you have multiple numbers, which ones do you pick? You're looking for the one that has an associated height with it. And sometimes you might be helpful to turn that page around. But even, you know what, frankly, even if you pick the wrong numbers, if you showed your work, you did the method right, you'll still mostly get full marks. You just pick the wrong number. Okay, so just moving on a little bit more here. So number 2, all I did was I just went straight to the answers and that was it. I just put the answers straight there for number 2 there. So 2A is 44.2 meters squared. B is 44.2 meters squared. C is 22.1. Did we all get there? Or no? Some of us did, some of us didn't. Okay. So 22.1 meters squared, 22.1 meters squared for D, 22.1 meters squared for E. So for number F, what do we notice about these calculations? Even if like you didn't do it, what do we notice about them? It's all the same lengths, right? It's all the same. It's 5.2 meters and 8.5 meters. So how come we don't have the same answers though for C, D, and E? Yeah, it's different equations. It's a triangle, right? And remember, triangle is technically half of a rectangle. If you look at what I do for C here, all I'm doing is I'm extending it out, filling in an invisible triangle there. Oh, well, all of a sudden we have a nice rectangle there, right? Same thing for this one here. If I was to do this, if I was to make you find the area of these two blue areas, if I was to make you add those both up, you would get the exact same answer you just got. You get 22.1 meters. Again, an area, a triangle, no matter what form it is in, is going to end up being half of a rectangle. Same thing for this one here. For E, if you were to fill in these blue things here, you get the exact same area again. Okay. What we're going to do then is we're going to zoom back up then to, we're almost done. Question 6. So we're going to zoom back up to question 6, and that is on page 7. So question 6 on page 7. My question for you is, why is this harder than other things we've done? Why is this the hardest question we've done so far?
Both 3D and multiple shapes.
So it's 3D and it's multiple shapes, right? That's exactly it. So we know that there's multiple sides to this. It's a 3D model, and then it's two things that are being added together, right? This is technically two different shapes here. So that's why this is actually a pretty difficult question. The math's not hard. We're finding the surface area of rectangles and squares, but how we apply it can make it difficult. And frankly, this is always that's the trades. Like you're dealing with like simple numbers. It's applying it that gets difficult. So without the math part of it, just tell me in plain English, how could I find the area of this? How do we think I could do that? I don't care about the numbers. I don't care about what I have to multiply. Just tell me in English. Or what are some things I need to keep in mind to find this? What are the complexities? You need to get all the sides for sure. And the tricky part there is that there's two different shapes. And so there's a whole bunch of different sides. So we've split it up into two different shapes. We're going to call this top one here. We're going to call this shape. What should we call it? I don't want to go ABC anymore. I'm going to go shape M. So the top one here, this little cube on the top, is shape M. The one down below is shape W. It's my initials. So we got M and we got W there. So those are our two shapes. Let's just find the surface area of each of them. Now, there's a couple things we need to consider. How many sides are on shape M? The top one. How come you're saying 5 and not 6?
It's a full figure. It's not two separate.
This is one whole figure. We've split it up into two to make it easier to calculate, but the bottom here is technically attached, right? It doesn't have a surface area because it's already built into the shape. So there's technically only 5 sides here. So I'm going to label these sides here. So, you know, side A, side B, and side C. Now, so we're gonna go, I'm just gonna put shape M up here at the top. So shape M. Okay, so we know that there's going to be 5 sides because there's just no bottom at all. There's no bottom at all. So for shape A, what am I going to multiply together here? Or sorry, for side A, what am I going to multiply together here? Doesn't quite tell us, right?
55 with the 27.
55 with the 20.
You subtract the 30 from 55.
30. Okay, so we know the whole height of this line here that my mouse is going across is 55. And we know that this bottom part here is 30, which means 55 minus 30. This side must be 25, right? You betcha. So we're using what we know to figure out what we don't. And then what's going to be the base of this A, of side A? How can I figure that out?
The 78 subtract the 45.
Yeah, the whole thing's 78 centimeters, right? But I know that this part here, which I do not need, is 45. So 78 minus 45 is going to give me 33 centimeters. All of a sudden, I now know that my base is 33 centimeters. And my height is 25 centimeters. Again, you use what you know to figure out what you don't know. You use the sides that you have to figure out the sides you don't have. So if I were to multiply these together, I'm going to end up getting, I could probably do this in my head, but I don't feel like it right now, 825 centimeters squared. Cool. That one's, ooh, 825 centimeters squared. Cool. Perfect. And now I'm going to go shape, I'm going to go side B. What am I multiplying together here? Well, isn't it 27? It's this line here, right? That's 27. If you're ever unsure, you can take a ruler, and I wish I, so if you're ever unsure, and I have rulers I'm going to be giving you guys. If you're ever unsure, when you get to these shapes, take your ruler, match it up, go across. Oh, there it is. The same side then, right? That's usually going to work. So if that's 27, that lines up, that's 27. Okay, that'll work quite nicely there. Wish I don't know where my ruler went, but I have sorry, my meter stick. I do have rulers for you guys though, specifically for this. Anyways, we know one of those sides is 27 centimeters. What's the other side?
25.
You betcha. It's 25 because we already figured that out. If I multiply those together, I should end up getting 675. I think. Cool. Old noggin's still working. And then for side C, what 2 numbers do I multiply there?
33, 27.
So yeah, so 33, we know that's the base. So that's the base on A, it's gonna be the top of A too. I hope that makes sense where we're getting these numbers here. So 33 times 27 centimeters. What's that gonna end up equaling out to? 800 and something. Oops. 891 centimeters squared. Okay. So I figured out the length of each side. Now what I'm going to do is let's just figure out what's the, so I'm going to write SA. What do you think SA means?
Surface area.
Surface area, you bet. Because again, I'm lazy. We can be lazy. So I'm going to say the SA of shape M I'm going to do that nice underline there, keep it nice and organized. So the SA of shape M, and I'm going to put some numbers here and let me know if it makes sense where I've got them from. Sorry, some letters. Does it make sense why I'm writing A, B, B, C? It's the sides, right? Again, we're being lazy. I know that, oh, side A is this. Side B is this. There's two A's. There's a front and a back. There's two B's. There's a left and a right side. And there's only one C. There's only a top, not a bottom. So I'm being really lazy because I don't want to write that all. But I know that, you know, it's two A's, two of these, plus two of these, plus one of those. And that's going to give you my answer there. You could also times them. You could do 2 times A plus 2 times B plus C, whatever works for you. But I'm just going to quickly add that up. Oops, make sure I add it up correctly. Plus 825 plus 18. Plus 675. Cool. So my total surface area for shape A or shape M is 3,891 centimeters squared. Cool. Now that's a lot of work. I am going to circle that, even though it's not the final answer, right? It's an important piece of information. So remember, the goal of you is not to, you're trying to make it make sense to you 2 months from now in the future, right? So 2 months from now, you'll look at this and be like, oh, that's pretty important. If you didn't circle it, you might not understand what that means 2 months from now. Cool, we've got shape M. What do we need to do next? Austin, what do you think our next step is?
The second shape.
You betcha, the second shape, shape W. I just named it whatever the heck I wanted. You could name it whatever the heck you want to. You could name it shape 1, you can name it shape A. You could, I don't know, name one Daisy, one Trixie, whatever works for you. How many sides are there going to be for shape W? How many sides here? This is a harder question to answer. Any guesses?
Wait, what? 6?
There's six sides here, right? There are 6 sides. Now, what's different here, though, is that normally all the shapes we've done, oh, the top and the bottom are the same. The top and the bottom are not the same here. It ends here, right? That's the line where it changes. So there's 6 sides, but if we label these, you know, I'm just going to say A here. I'm going to say B here. I'm going to say C here. There's also the bottom. Oh, I should have done whatever. It's too late. Done it. So there's actually 6 sides here. So there is side A, there's side B, there's side C, and there's the bottom. We've already done most of the hard work. So now we're just finding the numbers to multiply here. So what is going to be my, oh gosh, my dimensions for side A? What 2 numbers do I multiply together? It's getting messy.
Mm-hmm.
78, we know the base, 78 centimeters times by,
30.
you betcha, 30, right? The 30 over here, oh, that works over here as well. So 78 times 30 is going to give me, I should do this in my head, but 2,340 centimeters squared. Cool. For side B here then, that's this nice little side here. This one's kind of easy. It tells us right there, 27 and 30, right? Base times the height, 27 centimeters times 30 centimeters. That one we didn't have to try and figure out what it was from anywhere else. It just told us. So in this case, it's going to give me, oh, that's just going to be, yeah, 810. I don't know why I couldn't just do that in my head. 810 centimeters squared. Now for shape C, that's the one up here. That's probably the hardest one to figure out. Now we know the length of this one, right? We know this is 27 centimeters. It's the other length. Oh no, it does tell us. It's 45. Never mind. Times 45 centimeters. So if I multiply those together, that should give me 1215. Yeah, 1215 centimeters. So 1,215 centimeters squared. And then finally, we have our bottom. Which two numbers am I going to multiply there? You betcha. 78 centimeters times 27 centimeters. And if I put those together, that is going to give me, because I'm just too lazy to figure that out in my head right now, 2,106 centimeters. So there are 6 sides, and we have 4 different measurements here. So for the surface area, SA, of shape W, so for the surface area of shape W, what am I going to add together here for this? So for the surface area of shape W, okay, so a little bit more, yeah.
2 A's, 2 B's, and C in the bottom.
Yeah, so for the bottom shape, there's a front and a back. That's non-interrupted at all. There is, in fact, there's the 2 sides, the B's, there's 2 B's. Plus B plus B. There is this little top section here, there's C. And then there is the bottom. So does it make sense where I've gotten those 6 things from? 2 A's, 2 B's, 1 C, 1 bottom. I know we're labeling a lot of stuff here. So because I'm lazy and I don't want to input all these numbers here, you do not need to put 2,340 plus 2,340 plus 810 plus 810. If you've done this, I know exactly what you're doing, right? You can be lazy in a way that's organized still. So I'm just going to add all this together in my calculator now, right? So 2340 plus 2340 plus 810 plus 810 plus 1215 plus 2106. Okay, my total surface area, 9,621 centimeters squared. That's an important figure. I'm going to circle that. Am I done? No, because remember, the questions asked you to find the total surface area of this figure. I have found the surface area of the 2 parts of it. Now what I need to do, I just need to add those, right? So the surface area of shape M plus W. So that's going to give me, what is that? So 3,891. You could just write M plus W too. That works too. So 3,891 centimeters squared plus 9,621 centimeters squared. So I add those together to 1, 5, 13, 13,512 centimeters squared. This is my final answer. I also circle it. There are 3 things circled here, but like this is like a multiple step question, right? So it's a lot there, but we got it. Cool. Good to go. For the remainder of the time, sorry, I'll go back to there. Does everyone have that written down? No one is saying no, so I'm going to move forward then. So for the remainder of the time, what I want you to do is I want you to work on questions 3 and then just get as far as you can. Frankly, don't even worry about number 5. Like just skip it. We don't care about name and stuff. Sorry, curriculum. We have to cut some stuff out for time. Don't even worry about question 5. But so just head to page, was it 12? Yeah, head to page 12 and then just keep kind of going down there. Before you do though, I just want to give you a little bit of a brain teaser here by going back to what we were just looking at. So we found one way to do it, right? Yeah. There's another way I could have done this technically, and you're gonna discover this. You could have done it this way. You could have also split it up like this. That would work too. You could have split it up like that. Or there's a third way. You could have found You could have just extended it. Oh gosh, how do I? You could just find, like, let's imagine this is just a giant thing. There's a missing piece here. I could find the area of the whole thing
That's what I did.
and then take away that. That works. We are getting into questions now where you can solve it several different ways. That works. You can do it. Whatever works best for you, I'm cool with. Just make sure like I can follow along. That's why it's important to show the work. Okay, so page 12, page 12, and then just keep trucking away there. The goal is I want you guys to get up to question 15 if you can. Stop recording.